Hello, everyone. All right, we are going to move on with write and graph polynomial functions. This is a super short and easy section, and all it is putting together everything that we've learned about graphing higher order polynomial functions together so that we can actually get a picture. So remember, up to this point, we've talked about how to find the end behavior. The ends are going opposite, if they're both going up, both going down, or vice versa, right? We've talked about finding all the x and y intercepts. There's always a y-intercept, right? And then for x-intercepts, if there are x-intercepts, we just talked about how looking at the multiplicity of the factor that that x-intercept came from lets us know if the graph touches or crosses the x-axis at that given intercept. Okay, so we have all the tools that we need in order to graph it. So here's kind of our steps. We're going to find all the intercepts, find the zeros of the function. That's the same thing. It's weird. Determine the multiplicity of each zero. Determine the end behavior by examining the leading term. And then we're going to use all of this to sketch a graph. Now, I use the word sketch for a reason. Okay, we can make this graph super accurate by finding the end behavior, finding all the x-intercepts, and then plotting additional points. But a lot of times these graphs will shoot up to really high numbers or little teeny tiny numbers, and it takes a lot of extra effort to plug in all these little extra x values to get a very accurate sketch. So what I am looking for on this worksheet is your end behavior, your intercepts, whether you have touching or crossing correct, and then if you just have the correct shape. Okay, so I know it's going to be a sketch. So those of you who are checking your work using a graphing calculator, your sketch and your actual function graph may differ just a little bit. Okay, but again, I'm just grading to make sure you're getting that desired shape, okay, for the graph. So with that being said, there is a worksheet that goes with this section, and the way that I grade that worksheet is going to be exactly how I work these problems in this section of notes. Okay, so make sure when you're working your worksheet, you're showing all of the steps and finding all of the things that I'm going to be showing on these problems. Okay, all right, so let's go ahead and look at our first one. Our first one says sketch the graph of the given functions, and we have -2 times the quantity x plus 3 squared times x minus 5. So the first thing we want to do, remember, is determine that end behavior. So I'm going to go ahead and write here, we want to find our end behavior. Okay, and remember, we figure out what's happening at the ends based on that leading term. So I have to figure out what that leading term is so that I know which direction my ends are going, right? So notice from this one, I'm going to go ahead and write it. F of x is equal to -2 times x plus 3 squared times x minus 5. And remember, to find our leading term, we can just find the leading terms within each factor and multiply them together, right? So notice I'm going to have a -2, right? This is going to give me a -2. This one I have an x, but notice it's coming from a squared quantity, which means I'm going to have whatever that is, but I'm going to have it squared. So that's going to give me an x squared. And then this one, I have an x, and notice there's no power on that quantity, so it's just that x to the first power. So when I multiply all of those together, that tells me that my leading term is going to be -2x cubed. Okay, so remember, we can find our end behavior based on that leading term. So the negative tells us that the right side is going to be going down, right? And then the fact that we have an odd degree to this polynomial, right, tells us that the ends are going to be going opposite directions. Ends opposite. Okay, so I'm just going to sketch a little picture so that I know what my shape should look like. So the right side is going down, and if my ends are going opposite, then that means my left side is going up, right? And I don't know really what's going on in the middle. So we already have a good idea of what our shape should kind of look like. Now we need to find all of our zeros or intercepts, right? And I always start with a y-intercept because it tends to be the easiest one to find. So let's go ahead and look for our y-intercept. To find our y-intercept, remember, we're just going to set x equal to 0. So if I plug in 0 for x in my original, I get y is equal to -2 times the quantity 0 plus 3 squared times 0 minus 5. right? And then I just set each of those equal to 0, or sorry, no, I don't. I simplify those so that I can see what this equals. So this gives me -2 times 0 plus 3 is just 3, but then notice it's squared. So that's going to give me a 9 times -5. So -2 times 9 gives me a -18, and -18 times -5 gives me a positive 90. So I get y equals 90. Now remember, when we're solving these are representing points on the graph. So we need to make sure we write this as an ordered pair 0, 90. Okay, make sure you show me that ordered pair in your work, or it's going to be counted off on the worksheet. Okay, now if you look at our graph is a 20 by 20, right? And so we don't have 90 on our graph. So what I'm going to do is, if we ever have a y-intercept that is higher than 20 or something smaller than -20, I'm going to go ahead and just plot that point at the very top of the graph. Okay, don't extend the line or scale your graph or do any of that. Just plot it at the very top of the graph. Okay, because we're just looking for that good shape, and we'll do that here in just a second. So let's go ahead and find our x-intercepts so that we have all the information we need. So our x-intercepts, remember we set y equal to 0, and y is our f of x, right? So I'm just going to say set f of x equal to 0, right, or y equal to 0. So I get -2 times x plus 3 quantity squared times x minus 5 equals 0. And then I set each factor equal to 0. Now -2 doesn't have an x, right? So if it doesn't have an x, we don't need to set it equal to 0, because -2 is never going to equal 0, right? We can only solve for it if it has a variable with it. So we set our second quantity equal to 0, which is going to give us x equals -3. And then remember, we identify that multiplicity, right? So the multiplicity here, this came from a squared factor, so it has multiplicity 2. Anytime our multiplicity is even, remember that means it only touches the x-axis. So I'm going to say this one only touches. And I want to write this as an x-intercept. So this would be -3, 0. So this is everything I need to know about that intercept. Then I want to solve the next one. Okay. When I solve that second factor, I'm going to get x equals +5. Notice the factor that it came from, I only have one of it, right? So that means this is going to be multiplicity 1, right? Because I only have one copy. And 1 is odd. So if we have an odd multiplicity, remember that means our graph crosses the x-intercept. So I'm going to say cross, and then I'm going to write that 5 as an ordered pair, so 5, 0. So here's everything I need to know about that intercept. So now that I have my two intercepts, I know my end behavior and I have my y-intercept, now I can go ahead and do a rough sketch. So I'm again going to say rough sketch here, because this is not going to be a completely accurate graph, because we're not going to plug in a bunch of additional points. So when we draw our shape, we're really not going to know how high up our loops go or how far down our loops go, right? I'm just looking for the general shape of this graph. And for some reason, mine did not print very well. So I'm going to go ahead and just draw, trace over this x and y axis so it's a little bit easier to see. Can't really tell. I think it's supposed to be this line. Sorry, hopefully yours printed out a little bit better than mine did. All right, so we're going to go ahead and graph our y-intercept, which is up here at 90, which is the top. If you ever have a y-intercept that is larger than your graph or much smaller than your smallest y value, we're going to go ahead and just plot it at the top, okay? Because again, this is a rough sketch, okay? So now I want to go ahead and plot my two y-intercepts, which I have one at -3. And I also have one at 5, okay? So from there, we know that the one at -3 touches and the one at 5 crosses, okay? And then we want to look at our end behavior. We know from here, this side should be going down and this side should be going up, right? So if this side should be going up, then when it comes down and hits -3, notice it only touches. So it's going to go back up the same direction. I'm going to come ahead and go up here and go through my y-intercept and then bring it back down, and when we get to 5, it crosses. Okay, so that is going to be our rough sketch of this function. Okay, So again, I'm looking to make sure you have the correct intercepts, that they are touching or crossing, and that you have the correct in behavior and y-intercept. Okay, so notice when you graph this, if you were to type this into a graphing calculator and check, this may go way up here, right? And this may go way up, or it may come closer in. Okay, so again, this is just a rough sketch, but when you work this assignment on your worksheet, I'm looking for all three of these things. Okay, the in behavior, that you showed me what the leading term is, you wrote what the right behavior is, you write what's happening at the ends, draw me a little sketch, find the y-intercept, find the x-intercept, and then state at each x-intercept what the multiplicity is and whether it touches or crosses, okay? And then do your rough sketch. So I'm going to show you one more, and then I'm going to give y'all some to do. So this one, same idea. The only difference is this one is not already factored for us. So we're going to have to do a little bit more work. So again, we're going to start by figuring out what's going on at the ends. And to figure out what's going on at the ends, we need to look at our leading term here, right? So our leading term, we have f of x equals x cubed plus other stuff that we don't really care about, right? Our leading coefficient is a 1. It's a positive 1, which tells me that my right side, when I have a positive leading coefficient, is going to go up, okay? And then I have an x cubed, which is odd. And if it's an odd exponent or an odd power or odd degree of our polynomial, right, that means that our ends are going opposite. Okay, so I'm going to sketch a little picture. Right side's going up. If the ends are opposite, that means the left side's going down. And I'm not really sure what's going on in between, but it looks something like that. Okay, all right, so now we need to find our y-intercept. So to find our y-intercept, remember we're just going to set x equal to 0. So I'll get y is equal to 0 cubed plus 3 times 0 squared minus 4 times 0 minus 12. And when I multiply in all these little zeros, all those terms are going to go away, right? And I'm just left with y equals negative 12. Again, we want to make sure that we write it as an ordered pair. So as an ordered pair, this would be the point 0, negative 12, because we put 0 in for x, and we got negative 12 out for our y. Okay, and negative 12 is actually on our graph, right? So we should be able to plot it accurately. Okay, so now we need to find our x-intercepts. With our x-intercepts, remember we set our y equal to 0 or our f of x equal to 0, which means we're taking our original function and we're just going to set the whole thing equal to 0. So we have x cubed plus 3x squared minus 4x minus 12, and that equals 0. Okay, I'm going to go ahead and scoot this up so we have room to work it. So anytime we have 4 terms, we can solve it or find our zeros by factoring, and our factoring method is grouping. So out of the first pairing, I can take out an x squared, which leaves me with x plus 3. Out of our second pairing, we can take out a negative 4, which leaves me with x plus 3, right? And now that they both have an x plus 3, I can take that out, and I'll be left with x squared minus 4. Okay, now even though I can solve this by using the square root method, I'm going to go ahead and factor it if I can, just because we get our multiplicity from the number of factors, right? The multiplicity on the factor that the 0 came from. So if we can see the factor, it makes it a little bit easier. So this one is a difference of squares, right? Because x squared is a perfect square and 4 is a perfect square, and they're being subtracted. So all I have to do is factor that into the first base plus or minus the second base. So x plus 2, x minus 2 equals 0, right? And then I just set each of these factors equal to 0 and solve. So I'm going to get x equals negative 3, x equals negative 2, and x equals positive 2. Okay, so I'm going to go ahead and come up here and just write out all the stuff I need to know about those. So at x equals negative 3, I'm going to go ahead and write that as negative 3, 0. And notice the factor that it came from, I only have one copy of that factor. So it has multiplicity 1. Since it has multiplicity 1 and 1 is odd, that means it's going to cross at that x-intercept. Okay, then I look at the next one, I have negative 2. So I'm going to write that as negative 2, 0. Again, that factor I only have one copy of, so it also has multiplicity 1, which means it's also going to cross. Okay, and then our last one, we have x equals 2. So as an intercept, that would be 2, 0. It also came from a factor that I have only one copy of. So it also has multiplicity 1, which means that it also crosses. Okay, so these are all the things I need to circle that I need to know about each of my intercepts. Okay, so now that I know all of my intercepts and my end behavior, I should be able to go ahead and graph this function, right? So I'm going to go ahead and just rewrite my x and y axis because mine did not copy well. So hopefully yours copied good. If not, you can go over yours too. Okay, so I first want to go ahead and plot my y-intercept, which is down here at -12. And then I want to plot my x-intercept. So I have one at -3, one at -2, and one at +2. Okay, and then I want to go ahead and put my end behavior on my graph. I know that the right side goes up, and I know that the left side goes down. Okay, and it says that it crosses at all of these intercepts. So that means when I'm starting off here, this is going to come up and cross. Now, I don't know how high up this loop goes or how little this loop is. So again, this is remember, this is a rough sketch. So I'm looking for the shape, not how high the loops go. So I'm just going to go up a little bit and then come back down and cross this one. Now I do want to go ahead and go through my y-intercept and then come back up and cross through that last x-intercept. Okay, so when you draw this, you never know. You could go through the y-intercept and come down a little bit further and then come up through here, right? You could have drawn this loop lower or higher. Okay, I'm not going to be super nitpicky about that. What I'm looking for is to make sure you have all the correct x-intercepts, that you have correctly either touched or crossed at each one, that you have identified your y-intercept and that your graph goes through it, and that you have the correct end behavior. Okay? All right, so on the next, I believe, 2 pages, yes, there are examples for y'all to do. So go ahead and pause the video and work on those, and whenever you're ready to check yourself or if you get stuck, play the video and we'll go over it. All right, so here's our first practice problem. As you can see, this one is completely factored for you, which makes it easy to find our zeros, but a little bit harder to determine our end behavior because we have to figure out what our leading term or our leading coefficient would be, right? So we're going to get a 4 from this factor, we're going to get an x from this factor, we're going to get another x from this factor, and another x from this factor, which means that our leading term would be 4x cubed. So the +4 tells us the right side goes up. The degree 3 tells us that our ends are opposite because it's odd, right? So our little sketch should look something like this. And then we find our y-intercept by plugging in 0 for all of our x's, which leaves us with -72. Now, -72 is off the graph. So you can see here I just drew a little dot down at the very bottom at -20, okay? Don't draw it way down here off the graph, okay? Just put it at the bottom because, again, this is a rough sketch, okay? And then our x-intercept, we set y equal to 0, or in other words, we set the whole function equal to 0 and solve. So we're going to get 3 zeros here, right? 6, -1, and -3, and they're all multiplicity 1, which means they're all going to cross. So we know that the right side's going to go up, we know the left side's going to go down, and all we have to do is draw our line so that it crosses through all of our points and our y-intercept. Now again, if you're checking yourself on a graphing calculator, this may have gone way down here and done some big, huge, fancy thing. This may have been a tiny loop or a huge loop, okay? I'm just looking for the shape, the intercepts, touching or crossing, and the end behavior, okay? I'm not going to assassinate your paper because of how high your loops are, okay? But do make sure that it goes through your y-intercept, all right? Let's look at the second one. So on the second one, this one is not factored for you, okay? But that makes our ends really easy to determine because we can easily see what our leading term is, which is x cubed. Since our leading coefficient is a +1, we know the right side goes up. And because we have an odd degree, we know that our ends are opposite, which means if right side goes up, then left side goes down, right? All right, so then we find our, well, I did it backwards on this one. Usually we find our y-intercept, but apparently I did our x-intercept. So I'm going to go ahead and group in order to factor this, which gives me x squared that I can take out of the first pairing and a -9 that I can take out of the second pairing, which gives me x plus 1 and x squared minus 9. Now again, you could just set this equal to 0 and use the square root to solve it, as long as you don't forget your plus or minus. Or if you notice that this is a difference of squares, you can go ahead and just factor that into x plus 3 and x minus 3. Okay, either way is totally fine. So for those those zeros, you're going to get plus and minus 3, and then you're going to get -1 from that first quantity. They all have a factor, just one factor, so all of them is multiplicity 1, which means that they all cross at their corresponding intercepts. Okay, so, and then our y-intercept, if we put a 0 in for all of our x terms, we're just going to be left with this -9 out here, right? So our y-intercept is 0, -9. So we're going to go ahead and just plot those points. So we have our -3x intercept, our -1x intercept, our -9y intercept, and our +3x intercept. We know our right side's going up, we know our left side's going down, and we know it should cross through all those points. So we just go ahead and make that shape. Again, if your loop goes a little higher or a little lower on either of these, that's okay, as long as you have the correct intercepts, touching or crossing, and in behavior. Okay? All right, so that is the end of write and graph polynomial functions. There is a regular Knewton assignment as well as a worksheet, so you should now be able to complete both of those. If you have any questions, just let me know.